Hello, ladies and gentlemen, and welcome back. We're looking at A3 on our 2012 open paper. Let A, B, C, D, E, F be a hexagon, all of whose sides are equal in length and all of whose angles are equal. This is better known as a regular hexagon. And all of those interior angles, just while we're talking about it, will be 120 degrees. Just like the interior angles of a regular pentagon are 108 degrees. These are things that you might want to know, because it can save time in the long run. All right. The area of hexagon ABCDEF is exactly R times the area of triangle ACD. Determine the value of R. All right, so we don't actually need to know the area of the hexagon. We just need to know the relationship between this triangle and the total area of the hexagon. Okay, so how can I figure that out? Well, let's get a copy of our hexagon. We'll make it big, that way we can put things inside it. So I notice we've got A up here, B, C, D, and part of making this smaller triangle is AD, and that cuts my hexagon in half. So already I know what's left over here is half of my hexagon. Okay? So if I found out that, say, AC was, to pluck another number, if I found out this is 1/5 of this quadrilateral, which incidentally is also a trapezoid, okay, if I found that out, well, if it was 1/5 of this total trapezoid, and this trapezoid is half of the total hexagon, then a half times a fifth would be 1/10 of the total hexagon area. Okay, now I don't know it's 1/5, and I just tried to pick a number that wouldn't be true, because I know in the very first question for this contest I made a guess of 6 that turned out to be correct. Okay, so what can we do now? Well, I've got, if I sort of slightly rotate my, well, we'll keep it red. This A, B, C, D. This is a trapezoid. And it's equal to 1/2 of the hexagon. Alright? Okay, so first, how do I know it's a trapezoid? Well, to be a trapezoid, we'd have to have 2 parallel sides. We do indeed. How can I explain why? Well, if I extend BC a little bit, knowing that I've got interior angles of 120 here, what must this angle out here be? 60. And AD splits everything in half, so this full angle of 120 gets cut in half, and we get 60s down here. And so we have the nice little, I sort of call it the Z theorem. Looks like a backwards Z there, where this angle and this angle being equal tells me the lines are parallel. Or if the lines are parallel, it tells me those angles are equal. So they are indeed parallel, and you could even write down BC parallel to AD. Okay, great. So now we might just want to figure out, well, what's the relationship between the trapezoid and the triangle? Well, we have a height h for my triangle. I suppose we can make the triangle have a color as well. The triangle has a height of h, some base. I don't really care what, but we'll call it a base of b. And the trapezoid up here, the side length to our hexagon is A. So the area of ABCD is, well, what's the area of a trapezoid? It's 1/2, a height, and then A plus B. What's the area of triangle ACD? Well, it's 1/2 base times height. You see. Okay. So, where can we go from there? Well, if only I knew the relationship between A and B, that wouldn't be so bad. I think we probably could. I'm just trying to see if there's a simpler way. I was trying to avoid trigonometry if I could on this one. But, you know, maybe I can't. Well, okay. Instead of talking about it like that, this is a much nicer trapezoid than you might think. Okay, so if I draw this line here and we split at h. Now h is perpendicular to both sides. Why? Because they're both parallel. But now if I take this blue part here, I take it out and I reorient it, I can complete a rectangle. Okay. Yeah, is this necessarily what I want to do? Complete this rectangle and sort of take this out and flip it around. I'm honestly just trying to avoid trigonometry, and there might be a very simple geometric way to do this that is not coming to mind, and that's okay. As I've mentioned before, I don't read the solutions before I do this. So if I screw up a question that's very simple, I screw up a question that's very simple. So be it. But that would give me a nice little rectangle there. And so if we call this amount x, then a plus x is b minus x. It's still a height of h here, by the way. So total area in terms of I might just have to use this. Well, it wouldn't even necessarily have to be trigonometry. It would be a 30, 60, 90 triangle. So, yeah, I think that might just be for the best, is to try and do this with a 30, 60, 90 triangle. And hopefully this will leave me with a solution. So if I drop these h's here, I have some right angle triangles. Fine, to be expected. We got an A here, I've got an A here. But what are we going to have? Well, we'll have 60 degrees here, as has been remarked. It's a total of 120. If 90's already been taken off, we're left with a 30 here. So we get a 30, 60, 90 triangle. Okay. We know that these are also sides of the hexagon, so these are also A. And so 30, 60, 90 triangles are quite special because if the hypotenuse is a length 2, the side opposite the 30 is a length 1, and the side opposite the 60 is a root 3. Okay. So what would that tell me? If we've got an A here, we've got an A over 2 here, and an A over 2 here. And so B, that base, is a full 2A. Okay. And so we could continue on from here, but I think if I just go back to my area ABCD is 1/2 height. The height here will be root 3A over 2. Same sort of ratio work. So I don't even think I need the H. I'll show you why. H, A plus B, but of course B is 2A. So we get 3 over 2AH. And the area of our green triangle, what I really shouldn't have erased this. Well, I didn't erase it, I just drew over it. The area of ACD was 1/2 B. But of course B is 2AH. So it's AH. So ACD out of ABCD is going to be AH out of 3/2 AH. And that's going to be 2/3. So the green triangle ACD is 2/3 of my trapezoid, which is 2/3, and the trapezoid is 1/2 of my hexagon. So it's 1/3 of the hexagon. Now, what did we want? We actually wanted the hexagon was equal to r times my triangle. So just multiply by 3 on both sides. R is 3. So the hexagon is 3 times the area of that smaller triangle. I'm sure there probably was a faster way. I was just really trying to do my best to avoid trigonometry this early on. Okay. But there we go. 3 times the area of ACD, and we probably just want 3 written down there. Okay. So on we go to to question 4, where we're going to finish off part A.